Okay, so let's do a little review of solving systems of two equations. First of all, a system is just a set of two or more equations. And the solution to that would be any ordered pair or ordered pairs, because there can be more than one, that makes all equations true. So a little later on in the unit, we will talk about how we'll do three equations, but just for today, we'll talk about two different equations. And we can use something called substitution or elimination, but I'm going to do one example where I find the solution by using substitution. So if I have the system 3x plus y equals 20, and x minus 2y equals 10. There are multiple ways that we can solve this, but the concept of substitution is that we take one equation and get it alone. So for instance, the bottom one, I could rewrite as x equals 10 plus 2y, or if I did the top, it would be y equals 20 minus 3x. And since x equals 10 plus 2y, I can substitute that into the other equation. So if I take this x out and replace it with what x equals, we have, instead of 3 times x, 3 times 10 plus 2y, that's this part, plus y equals 20. Okay, and so just so we're clear here, these actually are two lines. What we're trying to find is the ordered pair, the x and the y, that make both equations true. So I'll show you at the end graphically what that looks like. If I were to solve this, then I'd have 30 plus 6y plus y equals 20. I subtract 30 from both sides, add the like terms together, and then I have 7y equals negative 10, divide by 7, y equals negative 10 over 7. And I know that's not a very nice fraction. I'm going to just leave it like that for now. If you wanted to, this does go in one time and there's 3 left over, so you could write it this way. But I think it's going to be easier to substitute if I just leave it as negative 10 sevenths. Going back to any of the three equations, the top one, the second one, or the second one rewritten, we need the ordered pair. So if we know y, we need to now find x. I'm going to use this equation since it's already solved for x, and now I'm going to plug in what y is. So x equals 10 plus 2 times negative 10 sevenths, because that's my y value. And then I'm going to solve. This is like 2 over 1, right? 10 minus 27. If I put 10 over 1 and make a common denominator, this would give me 77 minus 27, which is 57. So I can write my solution as an ordered pair, 50 over 7, negative 10 over 7. So this would be the solution algebraically to that system. just so you're seeing graphically what this looks like. If I would rewrite this as 20 minus 3x, and let's see, this would be 10 minus x divided by negative 2. Oops. So that ordered pair, 50/7 and negative 10/7, is the intersection right over here. Graphically, that's what it looks like. It is on both lines. So if I found the intersection, I see that I get these numbers, but 50 divided by 7 is approximately 7.14, and negative 10 divided by 7 is approximately negative 1.42. So graphically, when you're solving something, we've done that before, the solution is where the curves meet. Okay, this is what we would call linear. These are both lines. Let's do a system that is nonlinear. So nonlinear means that some or both things are not lines. So if I were asking you to solve the system y equals x cubed minus 6x and y equals 3x, just from my knowledge of functions, a cubing function looks like this and a line looks like this. It is possible that these meet in 3 spots. Now, they don't have to, but it's possible. So nonlinear systems are going to have more than one solution, potentially. The only way to solve a nonlinear system is to use factoring, or if it's quadratic, you could use quadratic formula. This is not, so my only option for this is factoring. We're going to kind of use substitution again. Since y equals x cubed minus 6x and y equals 3x, if these y's are the same, what I can just do then is say, okay, I'm going to take out the y down here and replace it with what's up above. I'm left with x cubed minus 6x equals 3x. So I'm going to use factoring and the zero product property, which means if I'm using zero product property, I want to have a 0 on the one side. So let's subtract 3x from both sides. And then I'm going to take out a factor of x. I could set this equal to 0 and solve it, or I could keep factoring since it's a difference of squares. So the 3x values would be x equals 0, x equals 3, x equals negative 3. But remember, solutions come in ordered pairs, so I have to find their y value as well. I'm going to go up here to the second. It does not matter. It should work in both equations. I'm picking the second equation simply because it's easier to work with. Y equals 3 times 0 or 0. So one of the solutions is going to be the ordered pair 0, 0. Let's put 3 in. So y equals 3 times 3 or 9. So a second solution should be the ordered pair 3, 9. Let's put negative 3 in. So 3 times negative 3 is negative 9. So a third solution is the ordered pair negative 3, negative 9. All right, so this did in fact indeed have 3 solutions. Let me just pull up a graph so you can see. So here we see the solution of 0, 0. The line and the cubing curve meet. This is the ordered pair negative 3, negative 9, and up here positive 3, positive 9. So be careful with nonlinear systems. Those might have more than one answer or one solution.